Hello. I'm going to show you how to make the litigation game with GameTreeCalculator. You may have seen this game on the home page, and you want to know how to create it yourself. The first thing I'll do is create the players. There will be a plaintiff and a defendant player. Over on the sidebar here where I see player 0, that is the default player, and I can rename this player to plaintiff. Plaintiff is going to have one piece of private information, which is that the plaintiff will always have an average situation. And so I will type average here and press save. Now I'll make the defendant player. Down here I can type defendant. And then press add player. Now I can expand the defendant player. And the defendant will have two pieces of private information. The defendant player can either be weak or strong. I will press plus here to add the strong private information. I want these two to be equally likely, and so I could type 0.5 in each of these boxes. Or I can just type 1 and 1. And when I press save, these will automatically scale so they sum to 1. Now that I have two players, I can go ahead and create the nodes. So I will start with the top level decision node, and I can drag this right onto the canvas here. When I click this node, if I go down here, the node properties appear, and to make that easier to see, I can condense these two panels, though I just see the node properties. And this is a decision which will be made by the defendant, though I can change the player to defendant, and the defendant can either offer to settle or say see you in court. And I can now press save and see that this decision node has updated. I will zoom out a little bit and then add the second decision node, which will go right here. This will be a decision by the plaintiff, and this is the plaintiff's decision in response to the defendant's offer to settle. I will give the plaintiff two choices here. The defendant can either accept the defendant's offer or say no way, see you in court, and then save. Now I want to connect these two decision nodes. I will do that by hovering over this black dot until it grows big, and then clicking and dragging up to this dot here and releasing. And now these two nodes are connected. Now, I can add the terminal nodes. I will drag some terminal nodes onto the canvas like this. Every path away through the game tree should end in a terminal node. By connecting these nodes to these spots here, I'll be able to make that happen. So there. Now you can see that every pathway through the game tree ends in a terminal node. Now it's time to define the payoffs for these terminal nodes. If I click this terminal node, I can see that I have this payoff function, the default payoff function, under node properties. Let's talk about payoff functions. The payoff function determines the payoff for every player. Payoff can depend on the private information held by all of the players. So the payoff function takes various arguments. The first one you should know about is the player. Player argument is going to be either 0 or 1 in this case. 0 being the first player, which is the plaintiff, and 1 being the second player, which is the defendant. And the second argument here is privates. This is an array into the private information for each of the players. I'll talk more about that when setting up the other terminal nodes. For this terminal node, I will stick with a fairly simple payoff function. And the way this works is this is saying if the player is player 0, then this will be the payoff. Otherwise, meaning if the player is player 1 or the defendant, Then this will be the payoff. And these two payoffs I will define as 1 for the plaintiff and -3 for the defendant. This is basically saying, if there's an offer to settle by the defendant and the plaintiff accepts, then the plaintiff is going to win $1 million. And the defendant will pay that $1 million plus an additional $2 million in legal fees. And now I can save that and make sure it's saved, and it is. Now I will talk about these terminal nodes. These ones will be a little more complicated. These are the cases where there's either an offer to settle and the plaintiff says no way, see you in court, or the defendant just skips straight to court. And in these cases, the payoffs are going to depend on whether the defendant is weak or strong. And so I can set that up by saying if privates index 1 equals strong, else if privates index 1 equals weak. And this will enable me to have two sets of payoffs. One if the defendant is strong, and another if the defendant is weak. And these payoffs are going to be if the defendant is strong, -2 for the plaintiff and 0 for the defendant. This is basically saying, because the defendant made an offer to settle and showed up in court strong, the plaintiff ends up paying the legal fees and the defendant loses nothing. If the defendant is weak, then the plaintiff is going to win $3 million. And the defendant will lose $5 million, meaning the defendant is going to pay $3 million to the defendant, plus another $2 million in legal fees. And now I will save this. I'm also going to copy this because I'm going to do something very similar in this terminal node. For this terminal node, everything is going to be the same except in the case when the defendant is strong. Players are going to split legal fees in this case, so each player will pay $1 million. And then I will press save. So here's the completed game tree, and now I'm going to be able to press this calculate button up here. And assuming I haven't selected any node, the calculator will do the calculation for all of the nodes. So I'll get to see the optimal strategy for the defendant, and the optimal strategy for the plaintiff, and also the expected values for all of the nodes on the game tree. So I'll go ahead and press calculate. And there you see the optimal strategy. Here I can see that the defendant should offer to settle 83% of the time and say see you in court 16% of the time. And if I click this book icon, I can actually see the details here. So if the defendant is weak, the defendant should offer to settle 100% of the time. If the defendant is strong, the defendant should offer to settle about 2/3 of the time and say see you in court about 1/3 of the time. The plaintiff strategy looks like this. The plaintiff is always average, so the plaintiff has that one piece of private information. And the plaintiff should accept the defendant's offer 1/3 of the time and say see you in court 2/3 of the time. Overall, the expected values from this game are listed right here. Though the plaintiff has an expected value of 0.67 and the defendant has an expected value of -2.67. Now I can run a little experiment here to see what would happen if either of the players deviated from the optimal strategy. For example, the defendant has this option here where I can fix the strategy. And so what I will do is say the defendant wants to offer to settle 100% of the time. I can enter that by saying offer to settle 100% of the time and see you in court 0% of the time. I'll press save and then I can recalculate this using that fixed strategy. I can see that if the defendant deviates, the outcome for the defendant will actually be worse than if the defendant had used the optimal strategy. And now another thing I can do is go back to the optimal strategy for the defendant and enter a fixed strategy for the plaintiff. Let's say the plaintiff wants to accept 0% of the time and say see you in court 100% of the time. I can save that and then recalculate. And what you can see here is that the plaintiff's expected value has gone down from 0.67 to 0.5 because the plaintiff deviated from the optimal strategy and chose this fixed strategy of saying see you in court 100% of the time. That was your introduction to the litigation game. I hope you enjoyed it, and if you have any questions, don't hesitate to press this button down here and ask questions.